Now you have example 11, given that f of x is equals to x square root of 3x minus 1. So you can see that here we don't we have not multiplied x square. We cannot multiply x square with the radical term, right? So we have to use the product rule in this case. Again, f of x is given as x square into square root of 3x minus 1. So what is u? The first term is u, that is x square. What is v? The second term is v, that is square root of 3x minus 1. So square root can be written as power 1 over 2. Again, we use the both the derivatives. So du by dx is basically 2x, and dv by dx is equals to, this power goes on start, 3x minus 1 raised to the power minus 1, and now variable is 3x minus 1. So the derivative of 3x minus 1 is simple 3. So when we simplify it, your answer will be 3 over 2, 3x minus 1 raised to the power minus 1. Do you understand till this step?
Yes.
Okay. After that, the derivative dy by dx is basically equals to u times du by u times dv by dx plus v times du by dx. So u is basically x square, and dv by dx is 3 over 2 into 3x minus 1 raised to the power minus 1 over 2, plus v is 3x minus 1 raised to the power 1 over 2, and du by dx is 2x, right? Again, you can see that this 3 over 2 can be multiplied by x square. So this can be written as 3x square over 2 times 3x minus 1 raised to the power minus 1 over 2, plus 2x times 3x minus 1 whole raised to the power 1 over 2, right? Now you can simplify it as this is negative power, so it will become it will be gone to the denominator. So 3x square over 2 times square root of 3x minus 1 plus 2x times square root of 3x minus 1. So this is the simplified answer, because it cannot be simplified. It cannot be simplified after this step. So this is the simplified answer. Do you understand or not?
Yes.
Okay. Any problem?
No.
Good. So the next example is example 12. Differentiate y is equals to e raised to the power x sine x. Now here we have again two functions. First function is exponential function. Second function is trigonometric function, right? So the first function u is e raised to the power x. The second function v is sine x. So e raised to the power x has the derivative same e raised to the power x, and sine x has the derivative cos x, right? And you can see that the formula is dy by dx u dv by dx plus v du by dx. First function as it is, derivative of second function. Second function as it is, derivative of first function. So it will becomes e raised to the power x, that is u, and dv by dx, that is cos x, and then v, that is sine x, and du by dx, that is e raised to the power x. You can see that e raised to the power x cos x plus e raised to the power x sine x. Here in both terms you can see that the e raised to the power x is can be taken as common. So it will becomes e raised to the power x times cos x plus sine x. This is your derivative using the product rule. Again, the second part is x times e raised to the power x square. Now this is your function, and the first function is u, that is x, and the second function is v, that is e raised to the power x square. And you can see that the derivative of first function will be 1. The derivative of second function can be found by simple method as well as by found the chain rule, right? So it will becomes e raised to the power x square is as it is, and now the derivative the variable is x square, what is the derivative of x square? That is 2x, so 2x can be multiplied. Okay, now we have all terms used in the formula, so we put u derivative of v with respect to x, v derivative of u with respect to x. Okay, so when we multiply, it will becomes 2x square e raised to the power x square plus e raised to the power x square. So you can see that e raised to the power x square can be taken as common, which is in both terms. So your answer will be e raised to the power x square into 2x square plus 1. This is your solution. Do you have any problem in this example?
No.
Okay, good. So here is the exercise 4. So exercise 4 has uh, total 5 questions. You can see that in first question, use the product rule to differentiate. We have to use the product rule in all parts. The first part is simple, second, third, fourth, fifth, sixth. The all parts are simple. We have to just apply the product rule in all parts. The first, this 4x square, this 2x, this 2x raised to the power 4, this x, this again x, this x cube, all are u, and the second one is v. Use the product rule to differentiate. Now this is u, this is v, right? Again this is u, this is v. Again this can be written as u, this is v, this is u, this is v. All the first terms are u and the second terms are v. So we have to apply the product rule to solve these questions. Okay, use the product rule to differentiate. Now in first question we have the first function and the second functions are algebraic functions. In second question we have first function, uh, or you can say that we have one function as a algebraic function and the second one is exponential function. In third question you can see that the first function or the one function is the exponential function or algebraic function and the second one is trigonometric function. So we just change our functions from algebraic functions, exponential functions, trigonometric function, because we have studied till now these three functions: algebraic functions which are x square, x cube, something like that, and exponential functions like e raised to the power x, e raised to the power x square, e raised to the power minus 2x. These are the exponential functions, and trigonometric functions are sine, cos. These are the trigonometric functions which we have studied. Okay, in part 4, question number 4, find the values of dy by dx at the on the curve. So first of all we have to apply the product rule on these functions using the product rule formula. The first function is u, the second function is v. After finding the uh, derivative using the product rule, we have to put the value of x, that is 2, 3 and 4 into the answer, and your specific answer will be the derivative on that point, right? So these type of questions we have done in previous exercises, as find, first of all find the derivative, secondly put the values of x into the derivative. Okay, the last question is that find the equation of the tangent to the curve at the point given by the x coordinate, this one, where x is equals to 1. So we have to find the equation of tangent. So first of all we have to take the derivative, secondly we have the value of x. So when we put x is equals to 1, so we have some value of y, right? So it means that when we have the derivative, let's suppose our derivative f of x will be some, when we put x is equals to 1, some 3. So this is basically m, that is slope. And when we put x is equals to 1, again we have value of x and value of y. Then we can find the equation of tangent by using the point slope form. Y minus y1 is equals to m times x minus x1, right? Do you understand?
Yes.
Okay.